Let's try going through a problem calculating the Gibbs free energy from some given information that we can calculate the equilibrium constant from. Suppose we were given the following reaction. Hydrochloric acid plus sodium methoxide creates sodium chloride and methanol. And suppose that we were given that the pKa of hydrochloric acid was -7 and the pKa of methanol is 16. From this information, calculate the change in Gibbs free energy of this reaction. Try this problem yourself before continuing with the video and seeing the solution. First of all, let's recognize that we can calculate the equilibrium constant from the pKa values that were given because this reaction is just an acid-base reaction. So let's write down the equilibrium constant equation, which would be as follows. Note that I did not write the net ionic equation, but it would be the same thing if we had done that. To help us see how the pK values can be related to this equation, let's add hydrogen ion to both sides of the fraction, and you see that this is just equal to 1, so it's perfectly valid to add this number. From this, we see that what I circle in green here, this is just 1 over the Ka for methanol. The rest of this stuff, what I circle in orange, this is equal to the Ka of hydrochloric acid. Therefore, we can rewrite the Keq as equal to the Ka of hydrochloric acid divided by the Ka of methanol. However, we see that we're given the pKa and not the Ka of the acids, so therefore we can simply convert this to Ka because we know that pKa is just equal to negative log of the Ka. So similarly, we know that this Ka is just equal to 10 to the 7th. This Ka is just equal to 10 to the -16. From here, we could find the Keq by doing this division, which comes out to 10 to the 23rd. Having found that the Keq is equal to 10 to the 23rd, we could now calculate the Gibbs free energy from the equation -RT ln K. Plugging in the gas constant, which is 8.314, multiplied by the temperature, which is 298 at STP, and the equilibrium constant that we solved for, which is 10 to the 23rd, we get -13.1 kilojoules. We see that the change in Gibbs free energy is negative, which means that this reaction is favored towards the products, and this is not a surprise because our reactants were a strong acid, hydrochloric acid, and a strong base, sodium methoxide.